angles. This is an introduction to trigonometry. We are going to learn what are positive and negative angles. Now, from the definition, an angle measured from the positive x-axis in an anti-clockwise direction is considered to be a positive angle. Now, an angle measured from the x-axis in a clockwise direction are taken to be negative angles. And this is what has been illustrated in the diagrams below. Diagram A shows positive angles. You can see the direction of the arrow there. The angle is being measured from the positive x-axis in an anti-clockwise direction. This gives us a positive angle. While in diagram B, the angle is being measured from the positive x-axis, but the arrow is pointing downward, right, in a clockwise direction. Now, any angle which is measured in this way is considered to be a negative angle. If there is any question, you can ask. Now we can illustrate how we can draw negative and positive angles using the knowledge that we are just from getting in the definitions of positive and negative angles. We are going to draw the angles that we have been given below. We want to draw angle. Just a moment. So we want to draw negative 60. From the definition, where is this angle going to be measured from? Remember, this angle is a negative angle. So it is going to be measured from the positive x-axis, but in a clockwise direction, right? Let me just use a different color so that you see what this means. So look at this. This is our x-axis, and this is a y-axis. So this is a positive x-axis, and the angle is negative 60. So we can't measure this angle going this direction, that is in an anti-clockwise direction. Because it is a negative angle, we are going to measure it from the positive x-axis in a clockwise direction. So this angle, negative 60, just to estimate, it can be here. So if it is measured in a clockwise direction, then it can be shown like this. Then this angle is negative 60. Or when we use the radian measure, this angle, which is negative 60, is equal to negative pi over 3. We can now draw the angle that is a positive 60. From the definition, since the angle is positive, it is going to be measured from the positive x-axis in an anti-clockwise direction. We can draw that. So we have the x or y plane for angles. Now let me change the color. We can use black. Black is going to make you see clearly. So the angle that we want to measure is positive 60. So positive 60 is a positive angle being measured from the positive x-axis in an anti-clockwise direction. So the arrow will point this side. And now you can see the difference from diagram A and B, how both angles differ depending on where it has been measured from and the direction that we have taken. Of course, we measure angles using a protractor. Now here is your work. Try to draw this angle for 180. Pause the video and try to draw it. Just follow the instructions. Now let's solve it together. How can we draw this angle? Well, this angle is a positive angle, which is positive 180. Or when we use radian measure, this angle is positive pi, right? So how do we draw that? So to draw this angle, since it is a positive, the angle is going to be measured. Let me just change the color. The angle is going to be measured from the positive x-axis. Remember, this is our positive x-axis. Even in this diagram, this is our positive x-axis. We have the positive y-axis, and there we have the positive y-axis. Now the angle we want is positive 180, or positive pi in radian measure. So it will start from the positive x-axis when you use your protractor up to the line 180. So this angle is what will be our positive 180 degrees. Okay, so this is what we have, and these angles are supposed to have degrees because they are in degrees. Alright, now we can discuss in detail the terminal angles. We can look at trigonometry at a right-angled triangle. Now, what we usually talk about when we look at a right-angled triangle, we consider the 6 trigonometric functions, or ratios, as others prefer to call it. Now, there are 6 ratios that can be formed by using a 2 length of the 3 sides of a right triangle. Now, each ratio in the triangle defines a value of a trigonometric function or ratio in a given acute angle. And so when you look at this diagram, you can see an acute angle, which you can see in green color. Now the functions or the ratios are, we have the sine ratio, the cosine ratio, and the tangent ratio. The sine ratio is abbreviated as sin, the cosine is abbreviated as cos, and the tangent ratio is abbreviated as tan. We also have cotangent, abbreviated as cot. We have the secant ratio, abbreviated as sec. We also have the cosecant ratio, abbreviated as CSC. This is the right-angled triangle you are able to see, and here it is 90 degrees. Depending on the corner or the angle, or rather the position of the angle, the sides we have, except hypotenuse, the opposite and the adjacent will change. In this case, we have the angle, this acute angle at this point, and that is why we have the opposite. The side which is opposite to the acute angle is called the opposite side, and the one which is perpendicular to the angle is called the adjacent. Now suppose the angle was upward here. Things were going to change. The opposite could have become what we have as the adjacent in this case. But the opposite and the adjacent will become what we have as the opposite. You need to keep this in mind, and you need to understand how these sides interchange depending on where your position of the given angle is. We can look at these ratios in detail. We have the sine ratio, which is defined to be equal to the opposite of your right-angled triangle divided by the hypotenuse. We have the cosine ratio, which is cos theta. Theta is the acute angle that we have. This is defined to be nothing but adjacent of our right-angled triangle divided by the hypotenuse. We have the tan ratio, read as tan theta is equal to the opposite of our acute angle over the adjacent. We also have the chord, the chord theta. Now, I wanted to show you how this is formed. Now look at this. We have the chord ratio. Now, chord is what we call the cotangent. Now, cotangent is equal to cos theta over sine theta. Now, we know what cos is from previous notes. Cos theta is equal to adjacent over hypotenuse, right? This is what you can see on top. This alone is cos, and this down is sine. So if you want to form the chord ratio, we divide cos theta over sine theta.